Cancer affects around 38% of the population and is treated most commonly with chemotherapy, radiation, or surgery. However, these treatments can have long-term effects on the health of cancer survivors. One of the main issues with chemo or radiation as a treatment is that cancers that are close to the ovaries, such as cancer in the pelvic region, can cause damage to ovarian tissue. Ovaries are responsible for releasing eggs out of things called ovarian follicles. Ovarian follicles are fluid-filled sacs that hold immature eggs, or oocytes, that are released from the follicle during ovulation. These follicles also create and secrete vital hormones into the body. This damage can cause infertility, early menopause, and stop the creation and release of these hormones. This can become a major issue with pediatric patients because the hormones are necessary for puberty as well as long-term heart and bone health. There are a few treatment methods for these issues, such as in vitro fertilization or ovarian tissue transplantation. However, none of these treatments are long-term solutions or able to provide a solution for pediatric patients. Because of this, a group of scientists at Northwestern University proposed a solution: artificial ovaries. The ovaries consist of a 3D printed layered scaffold around 15 times 15 millimeters that hold approximately 40 to 50 follicles. These scaffolds are printed with collagen-based gelatin because collagen is a protein that is abundant in both humans and mice and is biocompatible with the body. Gelatin was chosen because it is degradable, which allows for cellular remodeling as well as having soft and durable mechanical properties. To begin, trial scaffolds were printed at 30 degrees, 60 degrees, and 90 degrees and left to culture for 9 days in vitro or out of the body to determine which printed angle would best support the follicles. It was found that the 30-degree and 60-degree scaffolds best supported the follicles. The 60-degree scaffolds were then used for the in vivo studies or in the body based on their porosity, which allowed for better follicle seeding throughout the scaffold. The 60-degree scaffolds were then seeded with follicles and left to culture in vitro for 4 days to allow for cell interaction before they were placed in the ovarian bursa of 7 ovarectomized mice, or mice with their ovaries removed. The ovarian bursa is a thin membrane that surrounds the natural ovaries in mice and connects to the oviduct, or the tube that the oocytes pass through into the uterus. These mice were then mated with male mice to determine whether or not the artificial ovaries would produce offspring. 3 of the 7 mice with the artificial ovaries produced litters of 1 or 2 pups and were able to feed them naturally, showing that not only did the follicles survive, but they were also able to produce hormones necessary for milk production. These results are promising, and researchers hope to continue the development of these ovaries into larger animals and someday in humans.